Hello. Today, we're going to dive into the fundamentals of statistics by exploring averages and range. By the end of this lesson, you will be able to define and calculate the three main types of averages: the mode, the median, and the mean. You'll also learn how to calculate the range of a data set. Let's start with the basics. An average is a single number used to represent a whole set of data. We'll look at three types of averages. First, the mode. The mode, or modal value, is simply the value that appears most frequently in a data set. Think, quote, mode is most. Next, we have the median. The median is the middle value when all the data points are arranged in order from smallest to largest. Think median is middle. And finally, the mean. The mean is what most people think of as the average. You find it by adding up all the values and then dividing by how many values there are. Besides averages, we also want to understand how spread out our data is. For that, we use the range. The range tells you the difference between the highest and lowest values in your data set. A larger range means the data is more spread out. So to recap, we've defined the mode as the most frequent value, the median as the middle value of an ordered set, the mean as the sum divided by the count, and the range as the difference between the largest and smallest values. Now, let's apply these concepts. In this scene, our goal is to calculate the mode, median, mean, and range for a given set of data. Let's work through an example. Imagine 20 customers rated a restaurant out of 10. We want to find the mode, median, mean, and range of their marks. Here are the 20 marks they provided. The very first and most important step for finding the median and range is to put the numbers in order. Let's arrange them from smallest to largest. This ordered list is what we'll work with. First, let's find the mode. Remember, the mode is the most common value. Looking at our ordered list, we can see that the number 7 appears 4 times, which is more than any other number. So the modal mark is 7. Next, the median, which is the middle value. We have 20 values, which is an even number. This means there isn't one single middle number. Instead, we find the two middle numbers and calculate the value that's halfway between them. With 20 values, the middle is between the 10th and 11th positions. Let's find them in our list. The 10th value is 5, and the 11th value is 6. To find the median, we add these two middle values together and divide by 2. So 5 plus 6 is 11, and 11 divided by 2 is 5.5. The median mark is 5.5. Now for the mean. We need to add up all the values and divide by the number of values, which is 20. The sum of all these marks is 109. Now we divide this total by 20. 109 divided by 20 gives us a mean of 5.45. Finally, let's find the range. This is the difference between the largest and smallest values. Our largest mark is 9, and our smallest is 1, so the range is 9 minus 1, which equals 8. This tells us the spread of the customer ratings was 8 marks. We have now successfully calculated all 4 measures for this data set. We found the mode is 7, the median is 5.5, the mean is 5.45, and the range is 8. In this scene, our objective is to learn how to calculate averages and range when the data is presented in a frequency table. This is a common way to see data summarized. Let's use an example about the number of mobile phones people own. The data is in a frequency table. This table tells us that 4 people own 0 phones, 8 people own 1 phone, 5 people own 2 phones, and so on. First, how many people were surveyed? To find this, we need the total frequency. We just add up the frequencies. 4 plus 8 plus 5 plus 2 plus 1 equals 20. So 20 people were surveyed. Next, what is the modal number of phones? This is the number of phones owned by the most people. We look for the highest frequency in the table, which is 8. The value associated with this frequency is 1. So the modal number of phones is 1. Now, let's find the median. We have 20 people, so just like before, the median is between the 10th and 11th person's data once ordered. We can use the table to find where these people fall. The first 4 people have 0 phones. The next 8 people, so persons 5 through 12, have 1 phone. Both the 10th and 11th person fall into the group that owns 1 phone. This means the 10th value is 1 and the 11th value is 1. So the median is 1 plus 1 divided by 2, which is 1. The median number of phones is 1. What about the range? Remember, it's the highest value minus the lowest value. The highest number of phones owned is 4, and the lowest is 0. So the range is 4 minus 0, which is 4. Finally, let's calculate the mean. To do this from a frequency table, we first need the total number of phones owned by everyone. We multiply the number of phones by its frequency for each category, and then add those results together. So 0 times 4 is 0, 1 times 8 is 8, 2 times 5 is 10, 3 times 2 is 6, and 4 times 1 is 4. Adding these up, the total number of phones is 28. The mean is this total, 28, divided by the total number of people, 20. This gives us a mean of 1.4 mobile phones per person. Great! We've now seen how to handle data in frequency tables to find all our key statistics. Sometimes data is grouped into ranges or classes. In this scene, our goal is to understand how to find averages for grouped data. With grouped data, we can't find exact values, but we can find good estimates. Because we don't know the exact values within a group, we find the modal group, the group containing the median and an estimated mean. Let's look at this table showing the time it took 20 people to eat crackers. The times are grouped into intervals. First, the modal group. This is the easiest one. The modal group is simply the group with the highest frequency. Here, the highest frequency is 6, so the modal group is the time interval from 70 to 80 seconds. Next, which group contains the median? We have 20 people, so the median is between the 10th and 11th person. We need to find which group these people fall into. We can use cumulative frequency. The first group has 2 people. The first 2 groups have 2 plus 3, which is 5 people. The first 3 groups have 5 plus 6, which is 11 people. Since the 10th and 11th values fall within this cumulative total, the median lies in the 70 to 80 seconds group. Finally, let's find the estimated mean. Since we don't have exact times, we use the midpoint of each group as a representative value. To find the midpoint, you add the lower and upper bounds of the group and divide by 2. Let's calculate the midpoint for each group. For 50 to 60, it's 55. For 60 to 70, it's 65, and so on for all the groups. Now we treat this like a frequency table problem. Using the midpoints as our values, we'll multiply each midpoint by its frequency, sum those products, and then divide by the total frequency, which is 20. Calculating the sum of the products gives us 1585. Finally, we divide 1585 by 20, which gives us an estimated mean time of 79.25 seconds. And that's how you handle group data. You can't get exact answers, but you can find the modal group, the median group, and a very good estimate for the mean. So far, we've focused on central tendency with averages. Now, let's look more closely at spread or dispersion. Our objective is to define and calculate the interquartile range, or IQR. The range is one measure of spread, but it can be misleading if there are extreme outliers. The interquartile range gives us the spread of the middle 50% of the data, making it more robust. To find the IQR, we first need to find the quartiles. Quartiles divide an ordered data set into 4 equal parts. The first quartile, Q1, is the 25th percentile. The second quartile, Q2, is the median, and the third quartile, Q3, is the 75th percentile. We can find their positions in an ordered data set of size n using these formulas. The interquartile range is then simply the difference between the upper and lower quartiles. Let's calculate the IQR for the number of goals a team scored in 9 games. First step, as always, is to order the data. Here is the data in ascending order. We have 9 data points. Now let's find the positions of Q1 and Q3. The position of Q1 is at 2.5, and the position of Q3 is at 7.5. What does the position of 2.5 mean? It means Q1 is halfway between the second and third data values. The second value is 2, and the third value is also 2. Halfway between 2 and 2 is just 2, so Q1 is 2. Similarly, a position of 7.5 means Q3 is halfway between the 7th and 8th data values. The 7th value is 3, and the 8th value is 4. The value halfway between them is 3.5, so Q3 is 3.5. Now we can calculate the IQR. The interquartile range is 3.5 minus 2, which equals 1.5. This tells us that the middle half of their goal counts are spread over just 1.5 goals, indicating fairly consistent scoring. We have now successfully defined quartiles and used them to calculate the interquartile range, a powerful measure of data spread. In our final topic, we'll generalize the idea of quartiles to percentiles. Our objective is to define and calculate a specific percentile for a dataset. While quartiles divide data into 4 parts, percentiles divide data into 100 equal groups. They tell you the percentage of data that falls below a certain value. To find the position of the ATH percentile in an ordered dataset of size n, we use this formula. For example, for the 80th percentile, A would be 80. Let's find the 80th percentile for a set of 24 student test scores. Here are the 24 scores, conveniently already in order. First, we find the position of the 80th percentile. Using our formula with A as 80 and N as 24, we get 80 times 25 divided by 100. This simplifies to 20. So the 80th percentile is the 20th value in our ordered list. Now we just need to find the 20th score in the list. Let's count through our data. The 19th value is 71, and the 20th value is 76. Therefore, the 80th percentile, P80, is 76. What does this mean? It means that 80% of the students scored 76 or less on this test. Percentiles are very useful for understanding where a particular value stands in relation to the rest of the data. To conclude, let's discuss how to choose the right average for a situation. The objective is to understand the advantages and disadvantages of the mode, median, and mean, so you can interpret data critically. Using the wrong average can be misleading. Each one tells a slightly different story. The mode is easy to find, but since it doesn't use all the data values, it might not be a good representation of the whole set. The median's main strength is that it isn't affected by unusually high or low values. Its weakness is that it also ignores most of the data. The mean is often the best measure because it uses every single data point. However, this is also its biggest weakness, as a single outlier can dramatically skew the result. Let's consider an example. The ages of 30 people at a concert are collected. Most are teenagers, but there are 5 60-year-olds. The ages are mostly clustered between, say, 14 and 19, but we have these 5 outliers at age 60. The median age might be 17, and the modal age might be 16. These seem to represent the typical concert-goer well. However, the 5 60-year-olds will pull the mean age up significantly, perhaps to something like 25 or 26. If the band claimed the average age of their audience was 26, it would be technically true if they used the mean, but it would be misleading. In this case, the median would be a more honest representation of the typical audience member's age because it is not distorted by the extreme values. Today we have covered a lot of ground. We learned to calculate and interpret the mode, median, and mean, as well as measures of spread like the range and interquartile range. We've seen how to work with raw data, frequency tables, and group data. Most importantly, we've learned to think critically about what these numbers actually mean. Thank you for watching.